So the strained grid shell, the Frey-Otto Happold type structure, as a form of construction, makes its saving through low-cost standard components, very little cost in fabrication. Where it does cost money is in the time taken to construct it. The two UK examples of the Downland Gridshell and the Savile building are both cases where there was no time pressure on the construction. That's quite unusual, but they're both constructed in a public environment, and in both situations there were alternative facilities that were being replaced, but they were still being used at the same time as the construction. So there was no pressure to finish the job so that the new use could be implemented as soon as possible. And in both cases, the client actually got a lot of benefit through letting the public see the construction go on. It's a very unusual form of construction, very slow form of construction, very interesting for people to come and visit it. But in both cases, it's probably the assembly took 3-4 months because you're carefully manipulating a set of components into a shape, and to spend that long on a site needs very careful planning in both cases, because it was known that this slow process was going to go on. All the other operations on the site were put on hold. The contractor wasn't charging overheads during that period because they planned it into the whole process. It was just the cost of the carpenters doing the forming. On most construction sites, the big cost is the ongoing daily, weekly, monthly cost of having all the facilities on site just costing money. So on most construction sites, there's huge pressure to minimize the construction time. The enormous benefit of using timber fabrication, the benefit of CLT construction for high-rise buildings is that the components can be fabricated off-site, they can be brought to site and put together very, very quickly. And so for a noded type, prefabricated type grid shell, all the components can be made in advance and they can be brought to site and put up very, very quickly. So a project like the Scunthorpe Pods project, that was carefully thought out. The contractor used the components were fabricated with an understanding of what the construction sequence would be. So the nodes had fixing points for props. There was thought about how far ahead you could build without propping the shell, because you can cantilever parts of it forward. If you build a shell in rings, actually you need minimal support. And so the construction process is very predictable, very quick, very accurate, and so for a large structure you can put it up very quickly. So for a site, a more normal site, where where construction speed is essential, then a noded shell is going to be much preferable to a strained shell. So which is cheaper? Well, there's no question that the strained shell uses minimal quantities of material. So in terms of the amount of material, the cost of that material, the strained grid shell is going to be very effective. However, it needs very careful planning to make sure that the construction doesn't cost a lot of money. For the prefabricated shell, the prefabrication costs are high, because they will only be possible to do that work if there's access to sophisticated computer-controlled manufacturing facilities. But if you with that available, the fabrication, although expensive, can be done in advance, and the construction process can be very, very quick. So for a busy site with a congested space, then just-in-time delivery, where you deliver the components, put them up, take them straight off the lorry and put them straight into the construction, into place under construction, that can be a very cost-effective way of building the shell.